start. Note down. We'll start new chapter now. So work done. Note down. Work done by force. Work, power, and energy. Work, power, and energy. Note down. Now we will talk about work done in this chapter. Work done, kinetic energy, potential energy, okay, fine. Efficiency, efficiency, okay. Okay, so this work done. So note down work done by force. What is work done by force? So let's start with work done by force. So what do you mean by work done in physics? Okay. So what do you mean by work done in physics? So you have to understand this concept of in physics. What do you mean by work done? Suppose in our daily life, you say, if you ask any person, suppose this person is doing farming, okay. So you will say this person is doing farming. So what is the work of this person? Farming, correct? Or suppose engineer is there. Engineer is there. It is designing fan. So work of that person is designing fan, correct? Or mechanic is there, it will repair the motor. That is the work of that person, correct or not? Bus is there, bus driver. What is the work of the driver? To drive the car, okay, bus. So normally when you after your education, your status will be like this: working or not working, correct or not? Working or not working. If you join some company or hospital, you join some hospital, so it means you are working. You are doctor now, correct or not? You are working. Suppose you are not going to hospital, you are always morning to evening, night. You are always in your home, so you are not working, correct or not? Correct or not? So working, not working. You are doing something means working. You're not doing something, eating, sleeping only. So not working, correct? So that is the meaning of working in our daily life. But physics is different. Work done in physics is different. So first you write down the definition. What is work done by force? Note down. Note down. Work is work is said to be done by force if point of application displaces point of application displaces, okay. Work is said to be done means in physics I am talking now. I'm not talking on mechanic, engineer, doctor, farmer, no. I'm talking about work in physics. In physics, what do you mean by work done? Okay, so work done in physics means what? Who is doing that work? Who is doing that work? Force. We don't talk about mechanic, engineer, driver, okay, doctor, astronaut, okay. Now we talk about what? Force. So work is done by force. If point of application displaces, point of application displaces. What do you mean by point of application? What do you mean by point of application? You know force is a vector. Force is a vector. So where the force is acting, suppose this is the vector. So this is the point of application. Okay. Suppose I am exerting force on this board like this. So I am pushing this board. So this is the point of application where I am applying force. So point of application means, note down. What is point of application? Write down. Point of application means it is a point where force is applied. Force is applied, or force is acting. Force is acting. So like for example, I am holding this object. I am holding this object like this. Okay. I am holding this object like this. So what are the forces acting? Tell me. Mg downward. I am exerting two forces. How many fingers are involved? Two fingers. So one finger here, one finger here. So this finger is pushing it left, and this finger is pushing it right. Correct or not? So I am exerting one force here, another force here. So these are the point of application. Okay. These are the point of application. One point of application here, one point of application here. Okay. So these are the two forces. But where mg is acting, so center of mass, there is a center of mass. Roughly, where is the center of mass here? In the middle. Okay. So at the center of mass, this is known as center of mass. So at center of mass, what force is acting? Mg. So mg is exerted by earth. So where is the point of application of mg? Center of mass. We can call it center of gravity also. Center of gravity. Okay, it is a point. It is a point. It is a point where where weight acts. Weight acts. Okay, clear? It is a point where weight acts. So like for example this, I am holding this string. So I am pulling this string upward. So where I am exerting force? Here. Correct? If I hold it here, now where I am exerting force? Here. And for this mg is acting. Mg is acting here. Tension is acting here. Okay, so this is the point of application of tension. Okay, so this is the point of application of tension. So point of application you understand. Okay, point where force is acting. That point should move. That point should displace. So displacement should be there, S vector. Okay, so two vectors are involved here. Force is a vector and displacement vector. Okay, clear? So see, it should displace. Now in which direction it should displace? Along force. So suppose force is right side, displacement is also right side. So we call it positive work. We call it positive work done. Work done is a scalar or vector? Work done is scalar. Work done has no direction. Work done has no direction. Okay. So when force is along displacement, it is positive work done. When force is opposite to displacement, it is negative work done. Then it is known as negative work done. Okay. When force is perpendicular to displacement, it is zero work. Force is perpendicular to displacement. This is zero work done. When force is perpendicular to displacement. What if angle is there? Suppose this is F and this is displacement, angle is theta, then what is the work done? Fs cos theta. Good. So now you take components. What is the component of force along displacement? F cos theta. Very good. What is the component of force along perpendicular to displacement? F sin theta. So F sin theta will do zero work and F cos theta will do positive work. So F sin theta do zero work. Okay, note down. And F cos theta will do positive work. Note down. It will do positive work. Okay, clear? So what is the work done by F cos theta? What is the work done by F cos theta? F cos theta into S. Okay. So note down. All formula you write down here. So how work done is defined? In case of positive work done, it is Fs, force into displacement. In this case, what is the work done? Minus Fs. Minus Fs. In this case, what is the work done? Perpendicular. What is the work done? 0. And in this case, what is the work done? F cos theta into S. F cos theta into S. So you can write Fs cos theta also. You can write Fs cos theta. Understood? So formula is F cos theta. This is the force into displacement. Force into displacement. So work done is defined as force into displacement. So you can see once again, if they are parallel, force and displacement are parallel. So formula for work done Fs. Okay, positive. Force and displacement opposite. So work done is minus Fs. 90 degree means 0. If force is making theta with displacement, so Fs cos theta. Okay, clear? What if force is making more than 90? Suppose this is the force and this is the displacement and this angle is theta. Now how will you solve? So no problem, you can use this angle alpha. So you can solve like this. This is F. So what is the leftward component of force? F cos alpha. Upward component F sin alpha, correct? And this is S, displacement. So which force is doing work? Positive work. Work. Which force is doing work? This is doing any work? No. This is doing positive or negative work? Negative work. Correct. Good. So in this case, work done will be F cos alpha into S with minus sign. Okay, minus sign also. Work done is minus F cos alpha into S. Or you can also write F cos theta into S. You can write F cos theta into S. But theta is more than 90. So you can see theta plus alpha. What is theta plus alpha? 180. So what is theta? What is theta? 180 minus alpha. So what is cos theta? Cos 180 minus alpha. What is cos 180 minus alpha? Minus cos alpha. Good. Minus cos alpha. Okay. So cos theta will be minus cos alpha. So you will get same thing. So minus F cos alpha into S. Note down. So some numericals I am giving. You just tell me your answer. Suppose force is 1 Newton, displacement is 1 meter. What is the work done? 1 Newton into 1 meter. So 1 Newton meter. 1 Newton meter. Now Newton into meter is known as joule. So this is the SI unit of work done. Joule is the SI unit. Joule. Now you know that dyne is CGS unit of force. So what is the work done now? 1 dyne into 1 centimeter. This is known as erg. 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 Okay. Are you getting? Newton. Newton is the unit of force, but SI unit. Okay. Dyne is the unit of force in CGS. Okay. CGS system, and this is MKS. MKS is meter kilogram second. Meter kilogram second. And CGS means centimeter gram second. Okay. So for you just remember the relation. 1 Newton is equal to 10 raised to 5 dyne, and 1 joule is equal to 10 raised to 7 erg. Okay, note down. And dimension, actually we have not discussed dimensions. Okay, I will teach dimensions chapter also. So you know what is the dimension formula of force? MLT minus 2. And work done, what is the dimensional formula? ML square T minus 2. Okay, correct, good. I will teach this separately. I will teach. Okay, for a time being, you just remember. You just write down force means kg, 1 kg into meter into second raised to minus 2, and work done means what you write like this. What you write? Kg meter raised to 2 second raised to minus 2. Okay, so this 1 kg into 1 meter into second raised to minus 2, this is known as 1 joule. And oh sorry, this is Newton. This is Newton. This is known as 1 Newton, and 1 kg into meter square into second raised to minus 2, this is known as 1 joule. Correct? Now similarly, if instead of kg you take a gram, so 1 gram into 1 centimeter into second raised to minus 2, this will be called as 1 dyne. Okay, and for work done, what you write? 1 gram into centimeter square into second raised to minus 2. This is known as erg. 1 erg. Okay, clear? 1 erg. CGS, centimeter gram second. MKS, meter kilogram second. Okay, MKS is also known as SI, System International. System International. Okay, I will teach this topic separately. Okay, clear? It is a one chapter. It is actually we started with vectors. Okay, so don't worry, I will teach this once. I will teach this. Okay, so note down. So see, now come back to work done. So when 1 Newton is there, 1 meter is there, so what is the work done? 1 Newton meter. This is also known as joule. So 1 joule. 1 dyne in 1 centimeter. So what is the work done? 1 erg. Now you tell me 10 Newton is acting, 3 meter is displacement. So how much is work done? 30. 30 joule. Very good. 30 joule. 30 J. Now if I say kilojoule, what do you mean by kilojoule? 1000 joule. Correct. Megajoule. Megajoule is there. 10 power 6 joule. Very good. Okay, fine. Good. Millijoule. 1 millijoule, small m. 10 power minus 3. Okay. 10 power minus 3 joule. Okay, correct. So 1 by 1000 or 0.001 joule. Okay, clear? So these are some basics only, basics of units and dimensions. Okay, fine. So these are also very important, these things. Okay, that's why I'm discussing. Okay, fine. Okay, come back to topic. So when this is the force, this is the force, this is alpha, and this is displacement. So F sin theta, F cos alpha, displacement. So work done is equal to minus F cos alpha into S, or F cos theta into S. So now you solve this question. Suppose this is the force 10 Newton and this is the displacement. This angle is 120 degree. This is 120 degree. Displacement is 10 meter. Tell me how much is work done? Tell me how much is work done? You can calculate alpha. What is alpha? 60 degree. So minus F cos alpha into S. So this is minus 10 into cos 60 into 10. Understood? So minus 100 cos 60 value 1 by 2. So minus 50 joule. Minus 50 joule. Okay, done? Now let's apply some real examples. Let's apply some, chair is not there. Okay. Let's apply some real examples. Suppose this is the box or block. Mass of the block is M. So right now what forces are acting? It is a smooth block. It is a smooth block. So what forces are acting, tell me? It is a smooth block, horizontal surface. A smooth horizontal surface. What are the forces acting right now, tell me, right now? Mg downward, normal upward. Very good. Normal upward. You see any displacement right now? Any displacement? Is it moving? No, not moving. To move this, you have to exert force. So suppose I am exerting force F. Now I am exerting force F. So initially block is at rest. Now force F is acting parallel to surface. So now you find acceleration. What is the acceleration? How much acceleration? Tell me. Ma is equal to F. So what is the acceleration? F by m. Acceleration is F by m. So calculate displacement. Use S is equal to ut plus half at square. So what is the displacement? Tell me. What is u? 0. And acceleration is F by m. So what is the displacement? F by m, F by 2m into t square. Ft square by 2m. This is displacement. So what is the work done by force? Tell me. How much work done by force? So work done by F, work done by force F in t seconds. In t seconds, what is the work done? In t second, what is the displacement? Ft square by 2m. So what is the work done in t seconds? Fs. So F into S. Ft square by 2m. Okay, clear? F square t square by 2m. This is the work done. Okay, note down. Work done. Now, what is the angle between force and displacement? They are parallel. 0 degree. Correct? What is angle between normal force and displacement? 90 degree. So what is the work done by normal? 0. So work done by normal is equal to 0. And what is the angle between mg and s? Mg and s. 0. 90 degree. So work done is 0. So work done by mg is also 0. So how many forces acting? How many forces? How many count? 1, 2, 3. But which force is doing work? External force, correct. F. F is doing work. Normal is not doing work. Mg is not doing work. Okay. So I'm saying one statement. You tell me true or false. Any force, any force always do work. Always do work when any force. Okay, this is statement. You have to tell true or false. Any force always do work when there is displacement. When there is displacement. So true or false? False. Okay, you have to check angle also. Okay, check angle also. If angle is 0, then only work is there. If angle is 90, no work. Okay, fine. Now you solve this question. Suppose this is the person. This person is walking. Person is walking with constant speed. Constant speed. Person is walking with constant speed on rough surface. Person is walking with constant speed on rough surface. Suppose the speed is given v. The speed is given v. Speed is constant, remember. What is the work done by mg? Tell me. What is the work done by mg after time t? Mg is doing what work? Displacement will be how much? Vt. Displacement will be Vt. Speed is constant, correct or not? So what is the displacement? Vt, correct? Speed into time. So displacement is where? Right side. Mg is where? Downward. So what is the work done by mg? 0. What is work done by normal? 0. Good. Now you tell me work done by friction. It is going with constant speed. Like this. It is going with constant speed. It is going with constant speed. Constant speed means net force. It is a straight line also. This is a straight line also. This is straight line also. So velocity is constant. So what is the net force? 0. Very good. Net force is 0. So is there any horizontal force? No, there is no horizontal force. So how it is possible? Suppose I am walking with constant speed like this. It is also good physics in this. Suppose I am walking like this. So this one leg, this leg is pushing me forward, correct? But again I am putting this leg. So this leg is stopping me. Are you getting? Are you getting or not? So this leg is pushing me forward. Now this leg is stopping me. See, I am putting this ahead, front. Again now this leg is pushing me. This leg is stopping me. Correct? So sometimes friction is acting forward. Sometimes friction is acting backward. Again forward, then backward. Are you getting or not? So that's why net force is 0. Net force is 0. Speed is constant. Okay? Speed is constant. So what is the work done by friction? Tell me. Speed is constant, net force 0. So 0. So suppose person is walking with constant speed, no force is doing work. Normal is not doing any work. Mg is also not doing any work, and friction is also not doing any work. Okay, understood? Friction is not doing any work. I will tell you why. If suppose friction is acting right side, so it should accelerate. If friction is acting right side, the person should accelerate. Correct or not? It should accelerate. But according to question, speed is constant. Okay. So you can say net friction is 0. Net friction is 0. So friction is 0 here. Okay, because velocity is constant, so no force. So no horizontal force. No horizontal force. So when walking, okay, clear? Now instead of person, now I will consider block. Now this is the block. Now I am sliding this block. I am exerting force F. Now this block is sliding. Sliding where? Right side. So what friction will act? Tell me. What type of friction? Kinetic or static? Kinetic. So kinetic friction acts. So what is the direction of kinetic friction? Backward. How much is kinetic friction? Mu kn. Okay. But now this block is moving with constant velocity. Block is moving with constant velocity. So again, what do you mean by constant velocity? Net force 0. So external force and friction force both are equal, equal and opposite. So suppose constant velocity is v. So after time t, what is the work done by friction? After time t, what is the work done by friction? No, in this case it is 0. Person walking means work done by friction 0, because there is no horizontal force. I am simply walking like this. Is someone pushing me from behind? No. Is any person here? No. I am walking like this. So when you walk with constant speed, what is the work done by all the forces? 0. But now this is a block. Okay. Block is like this. Suppose this is the block. I am sliding it like this. I am sliding it like this. Like this I am sliding. Okay. So in which direction I am exerting force? Right side. Friction is where? Left side. And velocity is constant. So after time t, what is the displacement? Displacement is Vt. Now what is the work done by friction? Tell me. First you tell friction. So mu k mg, and displacement is right side. There, what is the angle between them? 180. So what is the work done by friction? Positive or negative? Negative. Minus mu k mg into Vt. Note down. Minus mu k mg into Vt. So, okay, so observe the difference. When person is walking, work done is 0. So how person is walking? No one is doing work. So how it is walking? So energy, it is using energy. It is using internal energy to walk. Okay. The person is eating food. Food is supplying energy. It can move legs. Okay. So to move legs. Okay. Energy supplied by food. Energy supplied by food. Okay. Are you getting or not? So food is supplying energy. So that energy is used by person to move legs. Okay, so person will walk. Are you getting or not? Now robot is you have seen robot. Now robots are also there. Okay, some huh? Okay, okay. Some countries have robots also. So robot eat food. Robot robot eat food. No, they eat current. Correct. What you say? Charge battery. So the battery will supply energy to robot. Robot will move leg and robot will walk. Correct. But this is different situation. This is different. Is there any leg here? Block. It is a box. No legs. So you have to exert force like this. I want this pen to move. You have to exert force. Is there any battery here or machine is there? Is it eating food? No. So you have to exert force. You have to exert force like this. So I am exerting force where? Right side. Kinetic friction left side. Constant velocity. Displacement is Vt. So what is work done by friction? Minus Fs. This is Fs. And what is work done by external force? Fvt. Fvt. Both are equal. So both are equal. So work done by F plus work done by friction. Tell me, what is the total work done? 0. Total work is 0. So you see in this block, total work is 0. Total work is 0. Okay. This force is doing positive work. This force is doing negative work. Correct? Total work is 0. So whenever any object is going with constant velocity, total work is 0. Remember. You can note down this point. It is a very important point. If a particle moves with constant velocity, if particle moves with constant velocity, so total work done. What do you mean by total work done? Work done by all forces. Work done by all forces is 0. If particle is moving with constant velocity, work done by all forces is 0. For example, here normal, mg, f, capital F, friction. If you calculate work done by all forces, W1 plus W2 plus W3 plus W4, okay, it will be 0. Work done by all forces is 0. So I can give one numerical now. Solve this numerical. This is 3 kg and you are exerting force on this. Mu k is given 0.3. Mu k is given 0.3 and it is given as constant velocity 10 meter per second. This block is going with constant velocity 10 meter per second. Find work done by this force. Find work done by force F, capital F, in 3 seconds. Tell me, what is the work done by force F in 3 seconds? Calculate. Now it is a numerical. So box is there, box, block. Block is there. What type of surface? Smooth or rough? Rough, rough. Same situation. It is going with constant velocity. So how much friction? Mu k n. Friction will be mu k n. How much is normal? Mg. External force not given, but you can find out. What is external force? Correct. External force is same as friction force, correct? They are balanced. Why they are balanced? Because velocity is constant. velocity is constant. So 0.3 into mg. So friction force is 9 and capital F is also 9. So what is the work done formula? Fs cos theta. Okay, so cos theta will be 1. So Fs. So 9 into S. Now what is S? Calculate S. S is equal to Vt. Acceleration is not there. 10 into 3. So displacement is 30 meter. So 270 joule. Work done by force F is 270 joule. If I ask what is the work done by friction, then what is your answer? Minus 270. Very good. So find work done by friction. So friction is acting left, displacement is right. Displacement is right. So work done by friction is minus 270 joule. And total work done, if I ask, what is total work done? 0. Very good. Total work done by all forces, by all forces, W1 plus W2 plus W3 plus W4, that is equal to 0. Okay, clear? Done? Okay, now I will give one inclined force. Okay, you are writing? Note down, note down. So this is, yes. So this 3 kg block is there, mu k is here, F is there, velocity is constant. Okay, velocity is constant. So work done by force F is positive, work done by friction is negative. Okay, displacement is Vt. Now one question on inclined force. Solve this. This is 3 kg. Now it is a smooth surface. Okay, it is a smooth surface, no friction. Now inclined force is there. This is the force, 10 Newton, and this angle is 37 degree. Initially at rest. Initially block at rest. Find work done by 10 Newton in 2 seconds. You have seen small kids, they play, they get some box, some empty box they get from somewhere. They connect one rope and they pull it. Correct? They pull it like this, and whole day they play like this only. Correct? Box is there. They are connecting it with thread, and they are pulling it. So this is pull or push? This is pull. Correct. Good. But it is frictionless. Frictionless. Okay. No friction. So calculate now. So you have to take components now. So take component. So what is the horizontal component? 10 cos 37. Vertical 10 sin 37. Normal where? Upward. Mg where? Downward. Friction? No friction. So this is the unbalanced force. This is the unbalanced force. So unbalanced force, how much calculated? How much? Correct. So 8 Newton. So unbalanced force is equal to mass into acceleration. So what is the acceleration? 8 by 3. So what is the displacement after 2 seconds? After 2 seconds, what is the displacement? Ut plus half at square. S is equal to ut plus half at square. What is u? u0, initially at rest. So u0. So what is the displacement? Half 8 by 3 time 2 square. So what is the displacement? 8 by 2 4 into 2 square, 4 by 3. So what is the displacement? 16 by 3. Displacement is 16 by 3. Okay. What is the question? Find work done by actually I have written wrong. Work done by. Find work done by 10 Newton in 2 seconds. Now, where is 10 Newton? This is the 10 Newton. And how is the displacement? Displacement is horizontal. What is the angle between force and displacement? 37 degree. This is force. This is displacement. Angle is 37. So tell me what formula you will use. Work done by force. Fs cos theta. Correct? Fs cos theta. What is force here? 10 Newton. S, you calculated S. 16 by 3. Cos 37. 4 by 5. So 10 into 16 by 3 into 4 by 5. So what is the answer? 16 into 4, 64. And 10 by 5. 10 by 5, 2. Correct? 128 by 3. Okay? 128 by 3 joule. Okay? 42.67 joule. 42.67 joule. Okay, done. Again, normal is doing 0 work. Mg is doing 0 work. Work done by normal 0. Work done by Mg 0. Okay. Only this force is doing work. So note down. So you are pulling this block. You are pulling this block on horizontal smooth surface. So take component. Unbalanced force. Unbalanced force is equal to mass into acceleration. Mass into acceleration. Calculate acceleration, displacement, ut plus half ut square. Okay, displacement you got. Use work done is equal to Fs cos theta. Look at force. Force is this. Displacement, angle, theta. Okay, done. Clear? Finished? Okay. Note down, note down. Half at square, then Fs cos theta. Okay, next. Now string and block. Now there is a string and a block. String and block. Note down topic. Suppose this is the block. I have a string also here. So this is the block. This is the block. This is the string. Okay. So right now, what is the displacement? What is the displacement? You see any movement? No. So what is the displacement? 0. But tension is acting. Tension is acting where? Upward. Mg is acting downward. So force is there. Tension is there. Mg is there. But displacement is not there. So what is the work done by tension right now? 0. What is work done by Mg? 0. Now I am pulling it up. Now I am pulling it up like this. Okay. I am pulling it up like this. So with constant velocity. I am pulling it with constant velocity. Okay. I am pulling it with constant velocity like this. So now you tell me what is the work done by tension after time t. So after time t, first you calculate displacement. What is the displacement after time t? If constant velocity is there, Vt. So displacement is Vt. So what is the work done by tension? Tell me what is work done by tension? Tension is acting where? Upward. Velocity where? Velocity where? Upward. So displacement where? What is the direction of displacement? Upward. Where it is going? Upward. It is going upward. So What is the work done by tension? Work done by tension, T S. Understood? And T and mg equal, correct? T and mg magnitude are equal magnitude. If mass is 1 kg, so 10 Newton, 10 Newton, tension is 10 Newton. If mass is 2 kg, so tension is 20 Newton. Why tension mg are equal? Because velocity constant, acceleration zero, forces are balanced. Good. Newton's first law. Forces are balanced. Okay, displacement upward, tension upward. So work done by tension is Ts. Now what is work done by mg? What? Minus, correct, good. Minus mg into s. Okay, note down. So work done by tension is mgvt and work done by mg is minus mgvt. Note down. Work done by tension is mgvt. Work done by hmm, work done by mg. Mg is acting where? Downward. Displacement where? Upward. So direction opposite. So when force and displacement opposite direction, force, displacement opposite direction, what is the work done? Minus Fs. Okay, here displacement is upward, mg is downward. So work done will be minus. Okay, understood? So minus mgvt. Clear? And if I ask what is total work, tell me what is total work? Zero. So total work means work done by tension plus work done by weight. Zero. Plus mgvt minus mgvt. Now the same block, I am moving down now. So what is the direction of velocity? Velocity is where? Downward. So now you calculate. Suppose this is the mass, this is the string. I am holding the block. Now I am taking it down like this. So constant velocity where? Downward. Mg is acting downward, tension is acting upward, velocity constant. So acceleration 0. So T is equal to mg. So what is work done by tension? Plus or minus? Minus. Very good. And work done by mg will be plus. And tension and mg both are equal. Now we have seen some example like so this example. In this example, what is the work done by mg in this example? What is the work done by mg? 0. Displacement is right side, mg is downward. Correct? Work done by normal is also 0. But in this example, what is the work done by mg? Minus mgvt, negative. But in this example, work done by mg plus. Okay. So work done by weight can be plus, can be 0, can be minus. Okay. Similarly, tension also. Here work done by tension is positive. Here work done by tension negative. So tension can do positive work, negative work, 0 work also possible. In this case, what is the work done by tension? Suppose I am rotating this string. This is string I am rotating like this. Like this I am rotating. So what is the work done by tension? What is the work done by tension? What is the direction of tension? Suppose this block is there, it is rotating, it is circular motion. When block is here, what is direction of tension? Upward. When ball is here, what is direction of tension? Horizontal. When block is here, what is the direction of tension? Horizontal. So velocity, tangent, here velocity, tangent, here velocity, tangent, here velocity, tangent. So what is the angle between tension and velocity? 90 degree. So tension is doing positive work, zero work, or negative work? Zero work. Okay. Tension is doing zero work. Tension is doing zero work. Note down this example. Okay. And write down ball is connected to a string. Ball is connected to string. Ball perform. Ball perform what type of circular motion? Vertical. It is vertical circular motion. This is vertical circular motion, correct? This is a vertical circular motion. So ball is performing vertical circular motion. Ball is performing vertical circular motion. So tension is perpendicular to velocity. Tension is perpendicular to velocity. So cos 90 0. Cos 90 0. So Ts cos theta. Ts cos 90 0. Okay. So work done by tension 0. Work done by tension is 0. When ball is here, tension is this way. Okay. This is the velocity. So velocity tension 90 degree perpendicular. Okay, clear? Okay. So now all three examples you see once again. I am taking this ball like this, constant velocity about. Tension is doing positive work. Now tension is doing negative work, correct? And in this case, tension is doing zero work. Zero. Okay. Now same thing with normal force also. Work done by normal force. Can normal force do positive work? Yes, normal force can do positive work. Suppose I am holding this object like this. What is a normal force? Upward, mg. Now I am moving it like this. So you can call it elevator. You can call it elevator. Suppose elevator means lift. So elevator is going with constant velocity, and this is the block. Like this it is going. So what is the displacement after time t? Tell me what is the displacement? Vt. So normal is acting upward, mg is acting downward. So what is the work done by normal? Tell me. What is the work done by normal? Positive. So work done by normal will be equal to work done by normal will be normal force into displacement, correct? Because velocity is upward, so displacement is upward. And what is the value of normal? Acceleration is 0. So normal and mg equal, correct? Normal is equal to mg. So what is the work done by normal? mgvt, correct? Work done by normal mgvt. And if I ask what is work done by mg, so minus mgvt, work done by mg. So if you connect a string, who is doing, I will talk about work done by tension. But now work done by normal. Normal is acting. Okay. Okay. Now I am taking it down. What is the direction of displacement? Downward. So this is the elevator. Now velocity is downward, constant. Velocity is constant. Block is there. Normal upward, mg downward. So now work done by normal will be, tell me, displacement downward. What is work done by normal? Minus n into s. So minus mg vt. And what is work done by mg? Mg vt. Work done by mg. Okay, clear, understood? So in this case, normal is doing positive work. In this case, normal is doing negative work. If I move like this, now normal is doing zero work. What is the direction of normal? Upward. Displacement? Right side. So normal is doing zero work, correct? Normal is doing zero work. Okay, clear, done. You revise it. So we can also do acceleration also. Now this is acceleration. Now this is acceleration. See, this is right now. What is the velocity? 0. Now I will accelerate it like this. Are you getting? Like this. So what is the initial velocity? 0. But now I am accelerating. So when acceleration is there, T mg. Now acceleration is there, A. So what is tension now? Tell me. T minus mg is equal to ma. So what is tension? Mg plus ma. And displacement, suppose initially at rest. Initially at rest. So what is the displacement? Initial rest. Ut plus half at square. U 0. So half a t square. Correct? This is displacement. Now what is the work done by tension? Positive or negative? Positive. Displacement is upward. Displacement is upward. So what is the what is the work done? Ts. M into G plus A into half a t square. Correct? Clear? And what is the work done by mg? Minus mgs. Minus mg is downward, displacement upward. So minus mg s. Okay, clear? Understood? So are you getting? Good. So this is 0 displacement, no displacement. So work done by tension, work done by mg, both 0. Constant velocity v. What is work done by tension? Mg vt. Work done by mg minus mg vt. Understood? But acceleration is there like this. This is acceleration. Okay. Initial velocity 0. So when acceleration is there, so t minus mg is equal to ma. Okay, let's solve one question. Write down. Solve one question. Block of mass 2 kg. Suppose this mass is 2 kg. Block of mass 2 kg is pulled up block of mass 2 kg is pulled up with acceleration g by 3, pulled up with acceleration G by 3 using string, using vertical string, using vertical string. Find work done by tension. Find work done by tension force exerted by string in 2 seconds. What is the work done by, what is the work done by tension force exerted by string in 2 seconds? So like this I am pulling it, like this I am pulling it. So what is the initial velocity? 0. Pulled up, initial velocity 0, starting from rest, initially at rest. Note down, initially at rest. So S is equal to ut plus half at square. What is u? U0. So what is S? What is S? Tell me. Half at square. A is given. A is given G by 3. So half G by 3. Time is also given. Find work done by tension force exerted by string in 2 seconds. So what is the displacement? 2 to cancel. 2 into G by 3. So what is the displacement? 2 square. So half G by 3, 2 square. 1 2 cancel. 2 2 cancel. So 1 2 is there. So 2G by 3, correct? So what is the displacement? 20 by 3 meter. Clear? This thing I have calculated, half at square. Half at square. Now what is the tension? Now calculate tension. What is the formula for tension? Calculate like this. Correct. So mg plus ma. M into G plus A. So what is the mass? 2 kg. G plus G by 3. So what is the tension? G plus G by 3. 10 plus 10 by 3. 10 plus 10 by 3. How much? Okay, 10 you can take common, no problem. 10 you take common. 1 plus 1 by 3. Okay. 4 by 3. 20 into 4 by 3. So what is the tension? 80 by 3. Okay, displacement you got, tension you got. Now what is the formula for work done? Ts. Okay, plus Ts or minus Ts? Plus Ts, because force, tension is upward, displacement is upward. So plus Ts. So plus Ts. So 80 by 3. Okay, tension is 80 by 3, displacement is 20 by 3. So what is the final answer? 80 into 20? Correct. 1600 by 9 joule. Okay, 1600 by 9 joule. Okay, clear? Okay, so work done by string. Work done by string. Okay. Note down. Any doubt? So now friction we will do. Friction, work done by friction, little bit we will study. Okay, done. So remember Fs cos theta. Now okay, solve this question. Block is released from top of the inclined plane. From what height? H. What is angle of inclination? Theta. Okay, it is a smooth surface. I'm not talking about friction. Let's solve this first. Okay, solve this. This block will slip. It will come here. What is the work done by gravity? That is a question. You can note down topic. Work done by gravity. Work done by gravity. Like this is also work done by gravity. We discussed no this. I'm taking like this. Displacement is S. Mg is downward. What is work done by gravity? What is work done by gravity? Plus or minus? Minus mgs. Now suppose like this. What is work done by gravity? Plus mgs. Very good. Okay. So here it is sliding. It is sliding down. So calculate work done by gravity as it comes from A to B. Find work done by gravity. Find work done by gravity as block. This is the block. As block slides down. As block slides down from A to B. What is the initial height? H. Initially rest. Initially at rest. Now calculate work done by gravity. So there are two methods. What is the acceleration? You know the acceleration? G sin theta. Acceleration is G sin theta. Now calculate this length of inclined plane. What is the length of inclined plane? This is the displacement. So L, displacement is equal to L. So we can calculate L, ut plus half at square. Actually time is, okay, suppose time taken is t, no problem. Time taken is t. So, but in terms of h also you can calculate. What is sine theta here? What is sine theta? What is sine theta? H by L. H by L. So what is L? H by sine theta. So this is the displacement. This is the displacement, okay? This is displacement. And mg is where? Downward. Now what is angle between them? What is angle between them? Tell me. This angle, what is this angle? 90 minus theta. So what is the work done by mg now? Fs cos theta. F is mg. S is L. And cos of 90 minus theta. What is cos 90 minus theta? Sin theta. And L is what? H by sin theta. Cos 90 minus theta cancel. So sin theta cancel. So what is the work done by mg? Final answer. mgh. Note down. Work done by gravity is mgh. Okay. So it doesn't matter. it does not depend what is L, what is theta. It does. If you know H, if you know mass, so what is work done by gravity? mgh. Okay, clear? It is independent of theta. Do not depend on theta. Do not depend on theta. Independent of theta. Length also does not depend. Does not depend on L. It is mgh. Okay, clear? So this is h. So what is the initial height? That is important. mgh. Work done by gravity is mgh. So suppose two inclined planes are there. One inclined plane like this, alpha, another inclined plane like this, beta. But what is same for both? Height. So block will come from here to here. Same block will come from here to here. In which case work done by gravity is more, or in both the cases same? Same, correct. So work done by gravity is mgh. In this case also work done by gravity is mgh. Okay, same. Smooth surface. It slide down. Okay, it's sliding down. So that is work done by gravity. mgh. Okay, done. Even if it is not flat, it is like this. It is like this, but smooth. This is a smooth surface. So this height is h. Then what is the work done by gravity? Same. The block will slide like this. So work done by mg is equal to mgh in this case also. Okay, clear? It is not flat. It is a curved. This is curved surface. Curved surface. Okay. So mgh. Now next you write down topic work energy theorem. Work energy theorem. Note down work energy theorem. Now we will discuss about energy. So which energy? Kinetic energy. So what is kinetic energy? What is kinetic energy? What is the formula for it? Half mv square, correct? So it depends on observer. It depends on observer. Okay, it depends on observer. Like this fan table. This table is there. What is the speed of the table? 0. So what is the kinetic energy of table? 0. Now if you put that table in a car, suppose this car is going right side. Now put that table okay in a car, and car is going with velocity v. Now two observers are there. Observer A, where is observer A? Inside car. And where is observer B? Outside. It is at rest. So according to B, this table is moving because table is inside car, car is moving. So according to B, what is the kinetic energy if mass is m? Half mv square. But according to A, what is the kinetic energy? 0. So kinetic energy depends on observer. Okay, clear? If according to observer, object is at rest, so kinetic energy is 0. If according to observer, object is moving, so kinetic energy is half mv square. So with respect to B, kinetic energy of table, this is the table, is half mv square, but with respect to A, kinetic energy of table is 0. Okay, kinetic energy of table is 0. Okay, clear? Kinetic energy depends on observer. Okay, come back to topic. Now, what is work energy theorem? So, note down statement. Note down. Work done by all forces. Work done by all forces is equal to change in kinetic energy. Change in kinetic energy. Work done by all forces is equal to change in kinetic energy. So you can write like this: work done by first force plus work done by second force plus work done by third force, and so on and so on and so on, is equal to change in kinetic energy. What is final kinetic energy? Final kinetic energy half m v2 square. V is the speed. Okay. What is initial kinetic energy? Half m v1 square. Half m v2 square minus half m v1 square. Okay. So just very basic question I am giving. To solve this, ball of mass 2 kg, ball of mass 2 kg changes speed from 2 meter per second to 3 meter per second. Find total work done on it. Find total work done on it. What is the total work done on it? So according to, what is the formula for work energy theorem? What is the work energy theorem? Total work done is equal to change in kinetic energy. So I am asking total work done. So that means what I am asking? Total work done means what? Change in kinetic energy. Very good. Change in kinetic energy. So change in kinetic energy means half m v2 square minus v1 square. Mass is 2. So 2 by 2, 9 minus 4. What is the unit of kinetic energy? It is energy. Energy means joule. So what is the unit? Joule. 5 joule. Okay, clear? So ball of mass 2 kg changes speed from 2 to 3. Work done is 5 joule. Clear? Okay, done. Now proof. How to prove it? So you see v square minus u square is equal to 2s. You know this? You know this, right? Now multiply by m by 2. Multiply by m by 2 on both sides. Both sides you multiply m by 2. What do you get? mv square by 2 minus mu square by 2 is equal to 2as into m by 2. What I am doing, you know this already. Now I multiply by m by 2. 2 to cancel right side. Now m into a is what? M into a, mass into acceleration. What is this? Force. So it is the net force. So it is net force into displacement. This is final kinetic energy. This is initial kinetic energy. So K final minus K initial is equal to F net into S, and F net into S is what? Work done. Correct? So change in kinetic energy is equal to total work done. Change in kinetic energy is equal to total work done. Okay, clear? Just remember this. It is not very important, but you just remember this also. Okay, so what is work energy theorem? Total work done is equal to change in kinetic energy. Total work done is change in kinetic energy. Okay. Now you solve this question. So this is the block M. This is smooth. Okay, this is the smooth surface. So tell me with what speed it is coming here. What is the speed? You have to find V. You release the block, it will slide. And what is the speed at the bottom of plane? V. What is the initial speed? 0. Okay. Find V. Find V. How to find V? So I am writing question also. Block released from top of smooth inclined plane. Smooth inclined plane. What is the speed at the bottom? This is given h. This is given. Okay. H. Tell me in terms of h. What is the speed in terms of h? What is the speed in terms of h? So who is doing work here? Which force is doing work here? Normal is doing any work? No, because displacement is down the plane. This is the displacement. Normal is perpendicular to plane. Normal is not doing work. Mg is doing work? Yes. Mg is doing work. Tell me, what is the work done by Mg? We have discussed already. What is the work done by Mg? What is the work done by Mg? Tell me. Mgh. Very good. So what is the total? Is there any other force? Is there any other force? No. N and Mg. So what is the total work done? What is the total work done? Add 0 plus Mgh. And total work done is equal to change in kinetic energy. So half m final velocity square minus initial velocity square, correct? So mgh is equal to mv square by 2, mm cancel. So v square by 2 is gh. So what is v? Root 2 gh. Okay, root 2 gh. Okay, clear? Understood? Finish? So block is released from top, from initial height h. It is released. Now sliding down, so coming down. When it arrive here, what is the speed? What is the speed? Root 2 gh. Okay. Okay, that's it. Now you revise this. I will continue next class. Okay. So this work done, revise. Okay. Okay, fine. We'll continue. Give me a book. I will give page number, question number. So this is work for energy. It is the next chapter. All these examples are there. You know this. Okay, go through it. This page 321. Question 1, 2, 3, 4. Page 329. All questions, question 1, 2, 3, 4, 5, 6. You can solve 7 also. 7, 8, 9, 8. 1 to 8. 1 to 8. 10. 14, 17. 20, 21 also. 27. 27 is very important. You can try now also. 27. Page 335. 36. 37. Page 337. You can solve this. Question 2, 3, 4. 7. 10. 7, 10. 22. Now come to this gearing up for NEET. Page 347. 346. Question 1. You know electron volt? What is electron volt? Correct. So you can solve one question. 5. 7. 12. 14. 19. Okay, so many questions you can solve. 14, 19. Okay. Spring don't solve. Okay. 39. 352, question 4. Page 352, question 4. Okay.